The empirical rule applies only to symmetric bell-shaped distributions. So what if the distribution is not bell-shaped, or what if the shape of the distribution is not known? This next theorem gives an inequality statement that applies to all distributions, and it is named after the Russian statistician Pafnuty Chebychev, which I'm probably saying wrong. So the Chebychev's theorem is that the portion of any data set lying within k standards, k standard deviations, k is greater than 1, of the mean is at least. Now this at least is very important. So it's going to give us a baseline, a bottom number, a minimum, that anything has to be above that. Okay, the percentages would be above that number. So your formula is right here, this 1 minus 1 over k squared. They give you two examples where if k was 2, they plug the information in, you do 1 minus 1 over 2 squared, and you would get about 75%. And then they do the same thing with k being 3. Remember, the k value is the number of standard deviations that you are looking at. All right, so let's put this into practice, and let's look at example 7. So example 7 says the age distribution for Georgia is shown in the histogram. Apply Chebychev's theorem to the data for Georgia using k equals 2. And what can you conclude? And it is an age of 100 unusual for a Georgia resident. Explain. Okay. So let's start by calculating the using Chebychev's theorem. So we want a k value of 2, which they give us right here. So we're going to take our formula of 1 minus 1 over k squared. We're going to do 1 minus 1 over 2 squared, which would be 1 over 1 minus 4, or 1 minus 1 over 4, and that's going to be 3 over 4, or 75%. Now, that was done above, so I kind of went through it pretty quickly. The idea is that your k value is what you're substituting. Often it's going to be k values of numbers like 2, 3, or 4, because that's the standard deviations or the spread that we're going to be looking at. So at 75% will be useful. And remember, that's at least 75%. So the number of, or the population of people that falls within 2 standard deviations should be a minimum of 75%. Could be much more. It could be 76%, or it could be 98%. But that 75% is going to be the minimum. All right, the next part of this is we need to look at the ages. So in this box here, they give us the mean, and they give us the standard deviation. So let's say the mean we're going to put in red, and the standard deviation we'll put in pink. So we're going to take our mean, and we are going to subtract 2 standard deviations from that. All right, because the question asks us, we want to apply Chebychev's theorem using a k of 2, so standard deviation of 2. Let's do some highlighting. If we were to do the math here and subtract this out, we get negative 7.3. Now, obviously, we can't have an age of negative 7, so we're just going to say that that's the minimum of 0. Right? Wouldn't go below 0 for ages. We want to do the same thing, but we want to add the standard deviations this time, because we need our top number. Okay, what is our higher end number? So we're going to highlight this 2 again to keep everything color coded so we know where these numbers come from. And when we add these numbers up, we get 81.9. So that gives us our top end number. So the question is, what can you conclude? So what color have we not used? We have not used, we'll go with this. All right, so what can you conclude? So we're going to highlight this. We can conclude that at least 75% of the population is between 0 and 81.9 years old. Okay. So you'll use Chebychev's theorem to get your percentages, and then you'll use this work here to find the bottom and top number, in this case in terms of your standard deviation. Okay. So the question is, or that's the first question, what can you conclude? So we can conclude that 75% of the population is between 0 and 81.9 years old. The next part of this question is an age of 100 unusual for a Georgian resident, and explain. Now, what do we consider unusual? So if you were to go back to the bottom of page 5 here, there's a statement that says data entries that lie more than 2 standard deviations from the mean are considered unusual, while those that lie more than 3 standard deviations from the mean are very unusual. So anything outside of 2 standard deviations is going to be considered unusual. So if we go back to the problem, is an age of 100 unusual for a Georgia resident? Well, 100 is definitely outside of that range. The range of 2 standard deviations went from 0 to 81.9. So since 100 is greater than 81.9, then 100 lies more than 2 standard deviations from the mean. Right, that 81.9 was our upper limit of 2 standard deviations. 100 is obviously greater than that. So 100 lies more than 2 standard deviations from the mean. So 100 is unusual.